Okay, previously we solved this system. I'm going to do this in a little more detail. So what we're going to do is we're going to take negative 2 times this row added to this row. Now you note my notation. I've got a 1 here to indicate that this is equation 1, a 2 here to indicate that this is equation 2. I'll indicate the equation by circling the number. And what I'm going to do is I'm going to rewrite this system of two equations. I'm going to rewrite the system by writing equation 1 down here. By equation 1 I mean the equation 1 from before. So that's 2x plus 3y equals 8. And then for the second equation, I'm not going to write the second equation. I'm going to write negative 2 times the first equation added to the second equation. I'm not going to write these numbers here. You can refer back to the earlier video to see where I wrote this down off to the side someplace. I don't want to write this down below here. I want this system to proceed, one system to another system to another system. I don't want to do my off the scratches, you know, what I would do on scratch paper to get these results. And what I would do in scratch paper is I would write negative 2 times this equation. That would be negative 2 times 2 is negative 4, so I'd have negative 4x. And negative 2 times 3 is negative 6, I'd have minus 6y equals negative 2 times 8 is negative 16. I would write that equation down, and then I'd write this equation down, and I would see that when I add the two, the x goes away. Now I can just refer to that because I assume that you're familiar with the way I wrote it out previously, and I can just point to this and say, well, okay, I'm doing negative 2 times the first row added to the second. What's that do to x? Negative 2 times the first means I'm going to take negative 2 times my 2x, giving me negative 4x, and then I'm going to add this to whatever I've got for x in the second equation, which is 4x. So I've got negative 4x plus 4x, that's going to give me 0. And I don't even need to write that term down, but I'm going to write it down just for completeness. Negative 2 times 3 is negative 6. Add that to negative 2, I get negative 8, or negative 8y, since I'm adding the negative 6y to the negative 2y. So I've got negative 8y. And that equals what? Negative 2 times the first plus the second. Negative 2 times the number here is negative 16, and the other number is 0, so I get negative 16. Okay, so I've reduced this equation to actually what we call upper triangular form. And I can easily now solve the equation. I solve this equation for y very easily. I get y equals 2. I can plug that back in here. I get 3 times 2 is 6. So I get 2x plus 6 equals 8. Subtract the 6, I get 2x equals 2. I get x equals 1. I'm not going to do that right now, but I could do that at this stage. Okay, so upper triangular form, and the 0 I wrote, I'm just going to kind of smear it out a little bit to indicate it doesn't need to be written. Okay, now I'm going to continue this process though. Okay, I want to continue this process to, first of all, I'm going to repeat the first equation, and I'm going to take negative 1/8 times the second equation. Now when I did this earlier, I said negative second equation, or second equation divided by negative 8. It says the same thing, but I like to do this, think of this as a multiplication, so I'll use the fraction. Okay, I'm going to repeat the first equation, 2x plus 3y equals 8. And then negative 1/8 times the second equation, negative 1/8 of negative 8y gives me y. Negative 1/8 of negative 16 is 2. So now I've got y equals 2. Still upper triangular form, but I've got a coefficient of 1 in front of y, so I could just take this value of y, plug it in here, solve for x, just like I said before. I'm going to actually take this a step further, and I'm going to now, I only want one variable up here. I know what y is. I want to get rid of y here, so I have an equation that's just in x. I do that easily enough. If I multiply this equation by negative 3 and add it to this one, I'm going to have a negative 3y here and a 3y here. It's going to give me no y. It's going to eliminate y from this equation. So I'm going to write this down like so. I'm going to do negative 3 times the second equation plus the first. And then I'm going to leave the second equation the way it is. Okay, so negative 3 times this equation, what's that? Negative 3 equals negative 6. Negative 3y equals negative 6, right? You might want to write that down if you're not sure of this. But so when I add negative 3 times the second equation to the first, I do that as before, term by term. So negative 3 times the x in the second equation, well, there's no x in the second equation, so negative 3 times the second equation is not going to give me any x, and I'm just going to still have my 2x here. So I've got 2x, and then negative 3 times y is negative 3y, add that to 3y, I get 0. And then I've got to do negative 3 times the 2 here, because that's in the second equation. Negative 3 times 2 is negative 6. Added to 8, excuse me, gives me 2. Now the plus 0, it wasn't necessary to write that. And my second equation, as I specified, remains unchanged. One more step. I take the first equation and multiply it by 1/2. And the second equation will remain unchanged. Okay, we're multiplying the first equation by 1/2. 1/2 of 2x is just x. 1/2 of 2 is 1. And y equals 2. And I've completed the solution of the equation. Now this can be written out in matrix form. In the matrix form, completely mimics what we do here. But I'm going to do this in terms of matrix operations, and I'll do that right over here so you can contrast the two.